As complement to the content of the maritime education, several video clips have been made as part of the Qualitätspakt Lehre QPL2 in the project MultiSimMan Green. In this video clip, the focus is on maneuvering the 200-meter ferry Mecklenburg-Vorpommern, which is underway with a speed over ground of 4.5 knots. Two different ways to carry out a similar maneuver will be demonstrated, initially by using solely the rudders, and in another video by the use of bow thruster alone. Concluding the maneuvers, an evaluation and comparison of both methods based on various characteristics such as maneuvering space required for maneuvers will follow. At the beginning, the vessel is underway to the initial maneuvering point at the speed of 4.5 knots without using rudder or thruster. A maneuver point represents the position or better situation where the rudder, thruster, or any other command is ordered. After 3 minutes, the vessel arrives at the first maneuver point and rudder is ordered to 25 degrees to port. The time required of the rudders to reach 25 degrees to port is small, which results in a steep increase of the rate of turn. Two minutes later, the increase in the rate of turn reduces and the vessel comes closer to a stationary turning with a stable rate of turn, causing a reduction in the speed ahead of the vessel. The required course is achieved after 6 more minutes. The rudder is set amidships at this maneuver point to stop the turning. Meanwhile, the ship's speed starts to increase due to reduction of resistance. The ship turns just a bit more than the required course to port, so a counter-maneuver is not necessary. After 90 seconds, the vessel arrives at the third maneuver point. The rate of turn is still at 5 degrees per minute to port, but it will be counted quickly as a starboard helm of 25 degrees is ordered now. The ship starts to turn to starboard side. At this point, the reduction in speed will be less than before, as the angle between the heading and course over ground, drift angle, is very small. In the next 6 minutes of the maneuver, it can be observed how the rate of turn is increasing in relation to the rudder order and subsequently the reduction in speed. Once the desired course is achieved, the rudder is set amidships again. Consequently, the rate of turn is decreasing. Another 3 minutes later, the rate of turn reduces to 2.5 degrees per minute. The ship's speed is slowly increasing and the maneuver is completed. To summarize, it has been seen that after ordering a rudder angle, the ship's speed decreases with an increase in rate of turn and vice versa when the rudder is set to amidships.